Back. Oops, I am muted. All right, we are back. So let's go ahead and go through what we're doing today. So first of all, we guys just finished doing a quiz on chapter 2.2, which is on your Jamboard. And then today we're going to finish up chapters 2.3 and started on 4.1, which is probability. You have a Connect Math due tonight, 2.1 to 2.2, and also you have your Excel lab due tonight. There's some questions about the Excel lab. We'll go over that in a minute. There's also some questions about the Connect Math people had, which we'll go over as well. So let me finish up this though. You can turn in the Excel lab late for full credit on Thursday. So it's due tonight. Try to get it done tonight. If you have any problems that come up, you can still turn it in late on Thursday and still get full credit for it. But it's due today, so really try to get that in today.
And for the next one, are you not going to make that exception?
No, it's true. Every Excel lab will be like that. You'll have a due date, and I know how life happens and things come up, so you can always turn it in late for full credit the following class.
Okay.
So next Tuesday you'll have another Connect Math and Excel Lab 2 due as well, and again you can turn it in late for full credit the following Thursday. Also, keep in mind you can borrow calculators and laptops from the library. The calculators you can check out yourself. Laptops you gotta go through me, but we can get you hooked up with one of those. All right. So yes. Go ahead.
So Connect Math, the schedule is kind of just like every Tuesday, every Thursday.
Yes. Exactly. Every Tuesday, Thursday, there is a homework due in Connect Math. Occasionally, I think 3 times a semester, there'll be a Saturday or Sunday one. I can't remember if I did pick Saturday or Sunday. I think I picked Saturday, but it might have been Sunday.
Okay.
That's due. But pretty much always Tuesday, Thursday, every Tuesday, Thursday, count on one. And like I said, I think there's 3 Saturdays throughout the semester. But if people want, I can change it to a Sunday, if people have a strong preference. Okay, great. So let's talk about one of the problems people had with this going in, which was you had something that looked like this, and it said something along the lines of, find the class width. Find class width. This is your homework. Connect Math homework. And it gave you something along the lines of this, like 14.6 to 17.8. That's all it gave you. Here's the deal. If I have 1 decimal place here in my class limits, these are things my data can be. I know my data is rounded to the nearest tenth. It's rounded to 1 decimal place. I know that because my class limits have 1 decimal place. So I know the next one, the next class is going to start with, well, since it's rounded to the nearest decimal place, the next one must be what comes after 17.8? 17.9. If you're not sure, just make this a whole number, 178. What's the next number? 179, and then put the decimal place back where it belongs. Now, you can find the class width, because then you'll know that the class width will be 17.9 minus 14.6. It's always going to be these two subtracted, or it could be these two too, but you don't know what this one is. So, but you do know it. You do know that 17.9 must be next, so you can find that one. Now, someone else said, well, so it's always going to be 1 decimal place? Not always. So say my data was like this, 18.96 to say 20.11. Now my data is rounded to nearest hundredth. It's rounded to 2 decimal places. So again, I'd say, well, ignore the decimal places. 2011, what's the number comes after 2011? 2012. Where's the decimal place go? After the 20, 20.12. So then, this would be the number that comes next. It's however many decimal places this is how many decimal places my data is in. So the next one I just add one more number in that last decimal place to here, and now I know that I would subtract 20.12 minus 18.96, and that's the class width. Right, which is equal to, I don't know, what is that, 1.16. I should plot it equal so you guys understand that what we're saying. This is equal to it. Select. Equals that, which equals, what's 17, let's see, what is that, 18 for 3.5, or 3.3, 3.3. Okay, questions? Is that making sense for folks?
It makes sense. Thank you.
Okay, good. So yeah, that was the biggest question people had about the homework. So I wanted to go over that a little bit. Maybe I will try to save this somehow. I don't know how to save it, so I'm just going to leave it. Okay, no worries. All right, so let's move on with, I guess I have to erase it. Clear? Okay, moving on. Excel Lab. So again, the Excel Lab instructions, you can find those by going to Canvas and you go home and go to Start Here. You will see it under Excel Labs with videos right there. Boom. And here's our Lab 1. You can click on that. That'll give you the description. The video will show you how to do it. I believe I have it here.
Actually, I did have a question about the video.
Yeah.
I was basically following it and I finished it, but towards the end you showed an example how to take the equations that we use for the data and like basically write out the equation, right? And then
Yeah, you don't need to do that.
I don't have to do that?
Yes. So there are two changes. Great.
Do I have to, if I already submitted it with the data, do I have to like resubmit it? Or
No, it's fine. That's okay.
Okay.
So there's two changes. There's two changes in general for all the labs. The first one is you are not printing them, right? So you're not printing them. Instead, you're submitting the Excel file. So you can ignore this printing part where it says print. Because of that, because you're printing them, then you do not need to give me the formulas. Right, there's something here about formulas. Where are the formulas?
It's towards the bottom.
Okay.
Second last page.
Professor Young?
Yeah.
I'm sorry. I think, I have a question regarding that document versus the video.
Yeah, I'm getting to that. There's one more thing. Let me finish first, and then we'll do that. That's okay. So those are the two things that are true for every single one. You do not need to copy the formulas, so you do not need to have a page of a formula sheet. So some of you guys, maybe we didn't have you guys do one here. I don't know, but you don't need to do a formula sheet because you're sending in the Excel file. The other thing that is different with this particular lab is this lab changed. So the video that I did for you is not quite complete. There are these two files at the very bottom that we've added to this lab after I did the video. So they're not on the video. You need to do these two charts also. So that's going to be one difference that's going to be different for this lab 1 is that the video did not show you instructions on how to do these because you don't need to do them. I mean, you didn't need to do them before, but you do now. They're new. Okay. Question, did I answer your question? If not, please ask your question now.
I answered it. Thank
Okay,
you.
great. Perfect. And don't forget, there's usually some questions we asked you. Maybe not in this one.
So we did need those charts.
You do need the charts.
Put them on the.
You absolutely need the charts, yes.
Okay.
If you did it without the charts, then add the charts and resubmit it.
The question.
Yeah, and the questions. You need to have questions and charts. The questions, where are the questions? I don't see them.
And number 5, on the instructions, on the procedure.
Up here. Yeah, here they are. Thank you. Yes, you do have to answer these questions. They're pretty straightforward, pretty simple, and they're not super easy. Maybe you're not quite sure, so maybe ask your these are great things to ask your neighbors inside when you guys are doing group work. If you have questions about that. But yes, you do have to do that. You do not have to do 4. Yeah. Right. This is probably the part. Oh no, you have to do that. You have to do 4. You don't have to do the formulas. Not sure where the sliding formulas are. The part about so you do have to do 4. Oh, this part here, H. Yeah, you're right. The last part of 4. So this one you don't have to do. G and H you don't have to do. Okay, great. And then Lab 2. So Lab 1 was just basically a basic introduction to Excel. All right, this is Excel. This is how it works. Lab 2 is kind of introduction part 2. It's not much harder. It's just some very, very basic, simple things as well. So let me go ahead and pull that one up for you guys. It might be here. Oh, this is Lab 1. Not me, Lab 1 twice. Lab 2. So again, it's pretty basic stuff. It's gonna walk you through creating a frequency distribution. It's gonna talk a little about bins, which are kind of weird and different, and I'm gonna ask some questions about that as well. I'll bring them up in the video. They're gonna ask them here. Just some things to kind of think about. Do your best with it. Creating a histogram, frequency polygon, saving them. Again, you do not need to create a formula sheet, and you do not need to print them because you're just going to submit the Excel sheet instead. But you should have these in there, and you should answer those questions. Answer the question in number 5. So there's going to be questions in number 5, which you can type right in here. Down here, you can just type in the answers down here if you want. So problem 5 will be these questions here. So kind of, a little bit. They make you think a little bit. Some of them don't have a right or wrong answer. And some of them kind of do. Yeah. I think A and B are kind of interesting. Yeah, go ahead.
So when I was trying to answer number 5 in the Excel Lab 1, I had trouble, I had to extend everything so that you can see.
Oh, yeah. Well, the thing about it is, it doesn't matter because you're going to be sending me the file.
Okay.
So I can just go in there and I can mess with it and make it work.
Oh, dang. Okay.
Yeah.
I tried, I had to, copy paste everything.
Yeah. Oh, sorry. Yeah, just go and type it in there. I can work with it. I'll figure it out. I can wrap it or I can do whatever I need to do with it.
Okay, I should have emailed you. Sorry.
That's all right, no worries. It's all good. Yeah, so just typically when you type in here, if there is nothing there, it'll just keep on going over, usually. Certainly when I scroll up here, I can see it when I go over there. Used to be that it would just kind of show up over there. But I guess maybe they changed it so it doesn't do that. It used to be that it would just overwrite things that didn't have anything in there. But I can find it, and I can scroll down if there's more, then I can find it as well if it keeps on going. It's all good. Okay. What else? Let's see. Oh, Excel, yeah, that's Excel Lab 2. So Excel Lab 2 due next Tuesday. watch the video, that'll help you. And then calculators on laptops. So if you want to borrow a calculator from the library, you'd go to our Canvas homepage. Also 365, Office 365 information is down here as well. So to get something from the library, you click on this, and you can just type in CI calculator. I tried it with the laptop, it does not work with the laptop. And it gives you these options. CI graphing calculator. You want the 84 probably. You can do the 83, either one's okay. And then they'll say, oh look, see how these ones are like available, reserves 4 hours or 1 hour. It doesn't matter because all the ones nowadays are for the whole semester. So even if you take a 4 hour one, it's going to be for the whole semester. And you have to sign in. You use your, I didn't do it, I spent like 5 minutes trying to figure this out last class. You use your class web username and your class web, so that's your W number, right? Your W number and then your class web password, class web PIN. And then that will get you in there to reserve that. If you want to reserve a laptop, email me. The other thing that is useful down here is at the very bottom, Office 365 for free. Do not buy Office 365. You get it for free. You click on that link at the very bottom of our homepage. You can also find it if you go to Start Here, where it says Excel right there. Click on that. They'll also give you that same link. If you scroll down a little bit, it's right there. And this is information on it. It's for all students. Can get it for free. You need your zone mail email address, which you can get through Canvas. You all have one. If you go to Canvas, you can find it in there. And then you have to, here's information on how to register. It steps you through everything you need to do to register for it. You can use it on the web, which is not quite as powerful. It doesn't give you as many options as if you download it. If you download it, then you can take it, you'll have it on your computer, right? The dilemma is if you do download it, then it's going to install this annoying app called Team, which uses up a ton of memory. So here's a little video on how to turn off Team. That's in, like I said, it's, if you go to Start Here, it's right here under how to say picture, the how-tos, right? So how-tos for Excel, it's right in there. Okay, so enough of that. Let's get on to actual classwork. Oh, actually, another quick prop about the concurrent support class. So that's going to be, you can get 1 point extra credit if you sign up for it and attend it. You have to email me after the exam to let me know that you're in it, and then tell me what section you're in and who your instructor is, and then I'll email them and confirm that you've been there and have been attending and participating, and then you can get 1 point extra credit on every exam.
Okay. Professor?
Yes.
I was just thinking because you brought up Excel. Are we going to need Excel for like the tests?
No.
Because I know during homework it says you can open it up in Excel.
No. No, you don't.
Okay, cool.
Yeah. Okay. Good deal. So Jamboard, quiz problem 1. The following data is the age of the students in a class, right? So it says class width of 5. Remember, whenever we have a class width of 5 or 10, whenever we try to get a class width of 5 or 10 whenever possible, and then, because then we can have our classes start on 5s or 10s, which is a lot easier for people to wrap their heads around. So it should either start or end on a 5. A lot of you guys did that. Go ahead and pop through the boards. You can kind of see people. Some people did start with the lowest one because the textbook has you do that, which is not really good, but that's okay. No worries. On the exams, I want that to start with 15. Here it's fine, but it's just easier. Like, look at this, and people, what it will do is it will make people have to focus on this harder to understand it. So they'll be using up some of their working memory on trying to wrap their heads around this, which which gives them less cognitive ability to look at this. So remember, working memory, you always want to make things simpler, right? So people just have an easier time looking at 15s, 20s, 25s, 30s. They can grasp this easier if you just look at this, versus versus that. It's just a little bit easier to look at. Okay, so these look good. Right, you guys all have this down pretty well. Good. All right, so yeah, so the relative and cumulative frequencies are in here. Perfect. Oh, that's right. Good. Next, we talked about histograms, right? So histograms always have the frequency or the relative frequency going up. The height is always the frequency or the relative frequency. And then along the bottom, there's a variety of different options. If you are using class boundaries, then they can touch. If you're not using class boundaries, if you're using class limits, they should not touch. And the other thing that's interesting that's really important is the boundary should be, it should be from here to here. The boundary should be on the ends of your your rectangle, not in the middle of your rectangle, because you're going from here to there. You're not smack dab in the middle of it. So I'll show you what I'm looking at, what I'm talking about. Let's see what people have. Yeah, this looks great. See, so the boundaries are all along here, and then they have the heights, and they're all touching. This is perfect. So the first class goes from 14.5 to 19.5, and it goes from here to here. Second class goes from 19.5 to 24.5, and it goes from here to there. Now, if you had it like this, like that, that would be wrong, right? Because 14.5 is not here. This is not where 14.5 is. 14.5 is right here. This is not centered around 14.5. This would imply that the 14.5 is its midpoint. And 14.5 is not the middle of it. 14.5 is at the lower end of it. So that's how you would lose points on the exam. You'd lose a fair amount of points, probably 2 or 3 points if you did that. Let's see what people have. Yep, there's another one, looks good. Quite get to it yet. Right, so these guys did classes, which is fine, but if you're going to do classes, then make them consistent. And more importantly, or equally importantly, they should not touch. Because you cannot tell me that this spot right here is simultaneously 19 and 19.5. No, leave it like it is. Leave it like it is. What I'm going to do is I'm going to show you what I want you guys to do instead. I want this to be not touching. Does that sort of make sense? Right, so then 14.9 should be centered, because it's saying that this block is from 14 to 19, and this block is from 19 to 24, and this block is from 25 to 29. So these guys should be centered below this, and that totally works. But if you're going to do that, then these should not be touching. Good? Either one's fine. There's a lot of different ways of doing histograms. Either of those are acceptable, but if you're going to do it like this with the class limits, then they should not touch. If you're doing with boundaries, then they should touch. Right, boundaries, they should touch. And this boundaries, these should be a little bit better. These are kind of wiggy, but you'll do better on the exam. So it won't be here. Right, so then these should touch, because you're using boundaries. I don't know where that is, but I'm sure you'll add another one over there. Okay. Yeah. All right, because you guys had slightly different whatchamacallits. Okay, great. So seems like people are all good with that. Looks pretty good. Relative frequencies. Oh, right. So relative frequencies are when you use the relative frequencies instead of the frequencies. So frequencies are actual whole numbers. How many people, right? The actual number of people. Relative frequency is the percentage of people. So these guys did relative frequencies. Beautiful, right? They're all percentages. 10%, 0.1. 20%, 0.2. Right? 45%. Right here, 0.45. That's relative frequency. That's awesome. Nicely done. I think a lot of people didn't because I didn't really give you guys, oh, some people did. Ah, nice job. So some of you guys did, a lot of you guys did well. So that's pretty impressive. Like half of you guys kind of knew to do that, which is pretty good. Because I hadn't really gone over relative frequency with you guys very much last class, so I was kind of worried that people wouldn't pick up on that, which is fine. But I do want you guys to start thinking about these relative frequency graphs, and in terms of the percent. You can do it as a decimal or a percent. Either one's fine. Typically they're decimal. Sometimes they're percent, I think, but usually they do them as decimal. I think it's slightly more common. Either is okay though. You don't see fractions though, so that's why. So that was your Jamboard quiz problem 2, which you guys did great. In later chapters, why am I reading? How about pick somebody whose picture I can't see? Eddie, go ahead, read for us.
In later chapters, there will be frequent reference to data with normal distribution. One key characteristic of a normal distribution is that it has a bell shape. Frequencies start low, then increase to high frequencies, and then decrease to a low frequency. The distribution is approximately symmetric, with frequencies preceding the maximum being roughly a mirror image of those that follow the maximum. Exactly.
Thank you so much. Right, so bell curves, they start off low, and then they kind of go high to the middle, and then they drop off and go low again. And they sort of look like a bell, if you're looking at, ringing a bell, and they're symmetric, with the highest point in the very smack dab middle. Uniform is where they're all about the same, approximately the same height, more or less. They don't move around a whole lot. They move around some, but not a whole lot. Right skewed is where you kind of have your data here, and then it kind of tapers off, kind of dribbles off to the right, like it got pulled. There's some far right things kind of pulling it off to the right, making it kind of outliers off to the right. Left skewed is when most of your data is here, and then it's going to kind of getting, I think of it like taffy, getting pulled, stretched out to the left. That's the way it kind of helps me remember left skewed and right skewed. There are other types of graphs: frequency polygons, ogives, bar graphs, Pareto charts, time series, pie graphs, dot plots, and then we're not going to worry about semi-leafs. We're just going to ignore those. Goodbye. Okay. Frequency polygons. These are really similar to histograms, only they use the class midpoints instead. Otherwise, they're pretty much the same. They use the midpoints, and then you draw a dotted line between them all. So let me show you what I would do if I was making this into a histogram. So here's my midpoint. The border lines for this class would be here, there, so you could totally make, it's easy to get from a histogram to a frequency polygon, or vice versa. Right, you can kind of see what I just did there. I just kind of centered it around and kind of moved it around. If I had a histogram, I wanted to make a frequency polygon, I would just make a dot in the middle of my histogram, because that's the midpoint, right? The middle of, from here to here, the middle of my lower boundary to my upper boundary, the smack dab in the middle is my midpoint. Put dots amongst all your midpoints, and then just draw a line connecting them. The catch is you have to anchor it in front, so you should make an imaginary class in front that you anchor it to. That has what's the frequency of this class? There is no class, so obviously it's going to have a frequency of 0. There's nobody in there. And at the end, you'd make another class at the end, right? Because this would go like this. And you have to make it imagine an imaginary class over here it would have a frequency of 0 as well. So you anchor it here and there. So let's go ahead. That's okay. We'll have you guys do it in a minute. So everybody is good with this part? This sort of makes sense. Any questions about this before we move on? Chats? Shall I look at my chat? Where's my chat? No, stop. Stop. Am I sharing my screen? I am, aren't I? Yes. Sorry, go ahead.
We're filling out the notes right now.
Okay.
Are we? Or are we?
I don't know that these are in your notes. Are they in your notes? Probably not yet. You will be soon. Probably not yet, is my guess. I don't think I've given you anything to do yet. But soon. Okay, so I'm going to go and clear this. So here is a regular frequency polygon. You can also have a relative frequency polygon, just like as you can have a relative frequency histogram or a relative frequency histogram or a regular histogram. So you'll notice, look at the picture, look at the graph. Everyone stare at this graph picture right here for a second. What changed? I'll go back. What changed? Don't worry about the words. I'm talking about the actual graph in here. What changes from here to here? The only it changes is these numbers here. They go from an actual count, how many people, to a percentage, a decimal. That's the only difference between a frequency and a relative frequency. That's it.
So basically, there's no difference.
Same height, same shape. The bottom stays the same. Yeah, the only difference is whether you are expressing it in terms of the percentage of the whole or the actual number of how many people. That's it. Histograms, again, can also use relative frequencies along the side or actual whole numbers. And ogives can do the same thing. They can either have relative frequencies along the side or they can have whole numbers along the side, either one. So an ogive is ones that use the upper class boundaries or the upper class limits, either one, and either the cumulative frequencies or the cumulative relative frequencies. Your notes says cumulative relative frequencies, but it also can be regular cumulative frequencies also. It can be either. But the idea of an ogive is that you're using cumulative frequencies and the upper class boundaries to say how many people were in that had that amount or less. Right? How many people were in that class or less. So how many people had that. If you use the upper boundary, then you know that they definitely ran that much or less. Scatter plots are these where you take the ordered pairs, x and y, and you plot them with x along the x-axis and y along the y-axis. So, for example, this guy way out here in the corner, he has a waist circumference of, looks like 138, and then he has looks like an arm circumference of about 42, 43, something like that. So his point would be labeled 138, 42 or 43 or something like that. I think you're familiar with these as well. And then we have bar graphs. That's where you use either horizontal or vertical bars to represent the frequencies or relative frequencies. And that's typically with categorical data. It can go sideways or up and down. This is the up and down, and you can also have two different things you're comparing at the same time, like boys and girls for each category. It's kind of useful. Pareto charts are only for categorical data. Categorical data, it doesn't matter what order I put these in. I could put train first, or bus first, or walk first. It doesn't matter. So a Pareto chart is when you arrange them in order from most frequent, highest frequency, to lowest frequency. So you start off high, and then the most frequent one first, and then the next one, and the next one, and the next one. So the most important one in a sense first, right? The most frequent one first. That's a Pareto chart. Time series graph shows how a variable changes over time. So time is always along the x-axis, always. And then the height shows you, where it is and how it changes over that time. So you can kind of see how the height changes. as you go along, along the timeline. Sometimes they have these as well, right? It goes by year, and then you have two things you can compare as it goes through. Pie graphs. Why am I reading? Grace, read for me, please.
Pie graphs are circles divided into sections according to the percentage of the total frequency that each category represents. Find the angle of any section, multiply the relative frequency by 360 degrees because there are 360 degrees in a circle. Perfect. Thank you so much. So, for example, married is 50%, right, of the graph. So there, as a decimal, 50% would be written as 0.50 or 0.5. Multiply that by 360 degrees because that's how many degrees are in a circle, and that would tell you how many degrees are in this section of your pie chart. We're going to be using, which you already have done if you've done your lab. You've already used Excel to figure out how to make the pie chart, so we're not really going to worry about calculating the decimals for that. And then dot plots. So dot plot is a statistical graph where we put a dot above kind of where its value is. So for example, there are no people who had an IQ of 90. There's one person who had an IQ of 91, one person who had an IQ of 92, 93, and then 94 had 3 people because there's 3 dots above it. You can kind of tell, that kind of gives you a, so at a glance you can kind of see, oh, they're kind of clustered around here, they're kind of, kind of up and down sort of, amount through here, and they kind of taper off, not very many off here and off here. So we're going to skip that one. So, lab problem 4, make a frequency polygon for your data. So this is lab problem 4. It is in your handout. I'm not sure if I have it up here. I should have it up here. No, sorry, that's wrong.
For the printout, it says lab problem 5.
Does it really?
Wait,
yeah.
No, 4.
It's
4. So this is the bottom of page 5. You turned in 5 last class, right?
Right.
This is the one you did not finish.
Oh, okay.
So this is the one you did not finish on the very bottom. This is it's the frequency polygon.
Okay.
So it's the one you didn't finish. So go ahead and finish that. And then, so again, it's that whole thing of, kind of taking your histogram, you've got your dot here, your dot here. Don't forget to anchor it in front and in back. And kind of, you have your dots, and then you draw the, I kind of put in all my dots, anchor it in front, right? Anchor it in back. So the midpoint should go, and then you draw your lines kind of between them all. Right, and that's how you get your frequency polygon. Now, you don't have to have a histogram first. You could do this, obviously, if you didn't have a histogram yet, you could totally do it without having done the histogram yet. And typically people do. So it's not typical that you do both. Right? Usually you do one or the other because they show the exact same thing. They're they're essentially the same thing. Right? They both show the same information. Okay. So go ahead and do that, and also answer these questions, the fill in the blanks from the word bank. So I'll give you guys, I don't know, 5 minutes to do this. Shouldn't take you very long at all. So 6:06, and then take a break. 6:06 to 6:15. We'll come back at 6:15. Or if you finish earlier, go to break earlier. Come back at 6:15. So, Ilya, Megan, Zachary, have you been in the room before, or are you guys just starting off now?
No, I haven't been in a room. I joined like 10 minutes late, so I haven't been in a room yet.
Okay. And Zachary?
Yeah.
What room are you in? Are you in a room? Are you?
No,
you're starting now. You're starting now.
Yeah.
Okay. Oh, sorry. You guys switched in room 9. My bad. Room 9.
This is based off the last class, then yeah, it was like 9.
No, actually, I'm gonna put you in a different room.
Okay.
I'm gonna put you in room